Alright, so here are some great examples of questions of textbook companies trying to be smart and try to freak you out a little bit. Anyhow, what we've got here, we've got these 6 problems as examples for what we're going to be up against. So first things first is fairly straightforward. With this is like 5a minus 2a. What do you get? Well, you get 3a. So this one, so we've got the same surds here. They're both the square root of 3. So we've got 5 lots of square root of 3 minus 2 lots of the square root of 3. What do we got? Well, we've got 3 lots of the square root of 3. Now for the next one, 3 root 11 minus 8 root 11 minus what root 11? What should go here? Well, just like with anything, if we don't have a constant coefficient, it is just 1. So here we're going to have 3 minus 8 to give us negative 5 minus 1 to give us negative 6. This ends up being negative 6 root 11. Oh, here's a good one. What do we do if they change the order of things? You don't do anything different at all. You're still doing the like surds. So 5 root 6, look for the other root 6 as well. There we go, there's one there. So 5 root 6, it might help to rewrite this. 5 root 6 minus 2 root 6. And then we've got plus 4 root 11 minus or plus 3 root 11. It helps to write it in order. You don't have to, but that's my advice. That's a line of working as far as I'm concerned. And remember, whatever the symbol is, that goes, whatever term you've got there, the symbol in front of it, it belongs to the term. So now we've got 5 root 6 minus 2 root 6. So just like 5 minus 2 over here, we are left with 3 root 6. And then we've got 4 root 11 plus 3 root 11, that's a plus as well, so that's plus 4 plus 3, so we have plus 7 times the square root of 11. Okay, now this one, we might look at that and say, oh no, we can't possibly add those two up, no way, we've got a square root of 8 there, we've got a 3 times the square root of 2 there, but if you've done a million of these, like you're hoping you have, you'll realise that this square root of 8 is actually 2 root 2. Wow. So then you say plus 3 root 2, and then 2 root 2 plus 3 root 2 gives you 5 root 2. Okay, likewise, we've got the same, a similar kind of thing here. We've got square root of 20. That square root of 20 can be written as 4 times 5 minus the square root of 5. So bring that out to make that 2 root 5 minus the square root of 5. Remember, if we don't have a coefficient, it is 1, so that's 1, 1. So 2 square root of 5 minus square root of 5, we're just left with the square root of 5. Okay, last one, square root of 6. Remember, we've got to put a 1 in there. Minus 2, square root of 24, 3 times the square root of 96. So let's see, what can we write these as? This is 1 root 6 minus 2. We're going to put some brackets in just to make it a bit easier. This 24 can be written as the square root of 4 times 6. So 4 times 6. And then this, we'll put plus 3. And I'm going to do brackets 96. What's the biggest factor of 96 that's a perfect square? Well, it's 16. So we have 16 times 6. I'm going to close that off. So we've got 2 root 6 minus this 4 times the square root of 6 can be written as 2 root 6. So 2 root 6 times 2 root 6 gives us 4 root 6. And let's say plus 16 root 6. The square root of 16 times 6 can be written as 4 root 6. So 3 times 4 gives us 12 root 6. So overall, we're going to have 2 root 6 minus 4 root 6 to give us negative 2 root 6 plus 12 root 6 gives us 10 times the square root of 6. So always make sure that they are simplified as much as possible. If you don't have a 1 where you think where there's nothing, put a 1 in there. If they have different surds, write them out in order before you go about adding or subtracting. And if they don't look the same, like if we've got an 8, a square root of, like in this case we had square root of 8 and square root of 2, they're clearly not the same, but you can rewrite this so it is in the form of the square root of 2. And then you just work the magic like you have been. But that's how you go about solving these types of problems.